So we have been given an equation of some curve equals sine 5x plus cos 3x. So dy by dx here is going to be, when I differentiate sine, I get positive cos. And if it's 5x, I'm going to do differential of 5x is 5. So we get 5 cos 5x. Now when we differentiate cos, we get minus sine. And because this is 3x, we're going to have minus 3 sine 3x. That should have been your dy by dx. And then we've been asked to find the equation of the tangent to the curve at a particular point where the x coordinate is pi. So we can say gradient of tangent is equal to 5 cos 5 pi minus 3 sine 3 pi. Now cos 5 pi, 5 times 180 is 900. Right, we're going to come to that. I don't want to work that in my head. So I'm going to go into calculator. Now, because I'm doing my angles in radians, I need to make sure that my calculator is in radian mode. So I'm going to go into setup and I'm going to change my angle unit to radians. And then I can type in 5 cos 5 pi minus 3 sine 3 pi. And we get minus 5. So that is the gradient of the tangent. We know that the tangent passes through pi and minus 1. So the equation of the tangent is going to become y plus 1 equals minus 5 x minus pi. And we can leave it like that. We don't want to do anything more than that ourselves. Maybe it's not new because you might have covered it in the integration, not the integration, chapter 14, logs and exponentials. They had a bit of this in there. So if y equals e to the x, dy by dx equals e to the x. Now what I want you to have a go at is to try and differentiate y equals e to the 2x maybe. Have a go at this. Let me know how you get on. If I'm not sure, I can always go back to the chain rule. So I'm going to say let u equal 2x. So y becomes e to the u, and du by dx becomes 2. dy by du equals e to the u. Well, now I can use the chain rule. dy by dx equals dy by du times by du by dx. And so we get here e to the u times by 2, which is 2e to the u, which is 2e to the 2x. Okay, 2e to the 2x, very important. It's not 2x e to the 2x. Okay, so if you're ever sort of stuck with it, go back to the chain rule. Now, next thing I want you to have a go at is y equals e to the 2x plus 3. Have a go at that and let me know as soon as you're done. Now, if you did the chain rule, what we end up getting is 2e to the 2x plus 3. Yeah, So now looking at both of these questions and seeing that what we are getting as our answers, what we realize is that if we have y equals e to the f of x, what is our dy by dx going to become straight away? I want you to have a guess at that maybe. Looking at the two questions that you have worked out, what is the general formula to differentiate e to the f of x? Right, yeah. So here, if I differentiate f, each time what I'm doing is differentiating the power, and that goes at the front. So f dash of x is going at the front, and what was originally there has remained there. So we end up getting f dash of x e to the f of x. Are you happy with that? Does that make sense? Right, okay, so just to sort of test you, y equals e to the 3x cubed minus 4x squared. I want you to have a go at this. Maybe use the general formula, but be careful in how you express your answer. If we use this formula up here, when we differentiate the power, we are going to get 9x squared minus 8x. So 9x squared minus 8x. The key thing here is to have that inside brackets because the whole of f dash of x was multiplied by e of f of x. Okay, so you could have written it like that, or you could have expanded it out. Now, obviously, you can multiply this by this and this by this. So you could have said 9x squared e to the 3x cubed minus 4x squared minus 8x e to the 3x cubed minus 4x squared. But as we can tell, the first version is going to be the best version to do that. Okay, and I'd recommend that you leave it like that. Okay, so check your working out. If you have made a mistake, let me know what mistake you made, and let's move on to the next bit of learning. I want to look at y equals ln x. If y equals ln x, what is dy by dx? You can quote this result. You don't have to prove it. In fact, the proof goes beyond what you need to know for now. It's 1 over x. Okay, so that's what we get here. Now, I want to get you to try differentiating y equals ln 2x, please. Have a go at doing that yourself. First time, use the chain rule regarding this and see if you can simplify that answer as well. Right, so I've got 2x, which is not x, so this creates a problem for me. So now I'm going to say let u equal to 2x. So y becomes ln u. And if I think about differentiating u, du by dx equals 2. what is dy by du? When you differentiate ln u, what are you going to get? You're going to get 1 over u, that's right, okay. So now, the chain rule. The chain rule is saying dy over dx equals dy over du times by du over dx. So dy over du is 1 over u, du over dx is 2, so we end up getting 2 over x. Not 2 over x, 2 over u. And we know u is 2x, so we get 2 over 2x, which can then be simplified to 1 over x. Okay, so what is ended up happening is ln 2x also has a differential of 1 over x. Okay, now can you look at your work and figure out where you went wrong and why you were not able to get this answer? And let me know in the chat as well. If we think about this here, we are going to make u equal to the thing inside the bracket. So y is going to become ln u. Du by dx is going to become 3. Dy by du is going to become 1 over u. And therefore dy by dx is going to become 1 over u times by 3, which is 3 over 3x plus 4. And there's your answer. Okay, so that's very good. All right, so let's make it a little bit more complicated. Any questions actually, first of all? Let's look at y equals ln 3x to the power of 4. So here I'm going to let u equal again the function inside the brackets plus 12x squared plus 5. So y becomes ln u. Du by dx becomes 12x cubed plus 24x. Dy over du becomes 1 over u. And so dy over dx is going to equal 1 over u times by 12x cubed plus 24x. Now again, important to multiply or put this inside brackets here. And so we end up getting 12x cubed plus 24x over, what is it? 3x to the power of 4 plus 12x squared plus 5. Now, can you simplify this? You cannot simplify this as it stands, by the way, because there's no common factor out of all terms that can be cancelled out because of this 5. Okay, so it's important to understand that this plus 5 will stop x's being cancelled out of each term. Right, okay, so we've looked at that. Now, hopefully you've realized that to get from here to here, my denominator essentially stays the same, and my numerator is the differential of the top. So in general, if I have ln of f of x, what is my dy by dx going to become? it's going to become f dash of x over f of x. Okay, so that general formula is something. Let's have a look if we can try and make sense of this. So if y equals x to the power of 7, what is dy by dx? Can you please tell me in the chat the answer to that? Yeah, very easy, 7x to the power of 6. Okay, so that's straightforward. Now, what I want to see is whether you can or maybe I won't go that complicated. Maybe I will. I want to see if you can do this yourself. We have got a function within a function here. So my thought process is let u equal 2x cubed plus 5x. So y is going to equal u to the power of 7. Du by dx is going to equal 6x squared plus 5. Dy by du is going to equal 7u to the power of 6. And we actually want dy by dx. So dy by dx, again using the chain rule, dy by du times by du by dx. So dy by du is 7u to the power of 6. Du by dx is all of this thing here. So I'm going to multiply that by 6x squared plus 5. And so we end up getting 7 2x cubed plus 5x to the power of 6, 6x squared plus 5. There's your answer. You can, of course, have written it in order of multiplication, doesn't matter. So it's a times b times c. So if I do a times c times b, it's still the same thing. Yeah. Okay, so now you can understand. So here, you can go through all of that. I'm going to teach you now a shortcut to using the chain rule for this. Or maybe you've probably already spotted it. Bring the power down for the bracket. Take one away from the power of the bracket. And then what we want to do is multiply by the differential of what's inside the bracket. So 5 minus 2x. Right, so the shortcut, bring the power down, take one away from the power, multiply by the differential of the bracket. So you're not sort of wasting time on a question like this in your exams or something like that. Yeah, I figured that one right. So bring the power down, take one away from the power, multiply by the differential of what's inside the bracket, 6x minus 5. That's it, done. Nothing more needs doing, and you've sort of done that in about 30 seconds or something like that. Okay. So that is the chain rule for sort of anything inside bracket to any powers. Right, okay, let's have a look at some dodgy questions. I feel as if I've prepared you quite well, and maybe you won't find anything too tricky now. I shouldn't do. Oh yeah. Oh, here we go. I was chatting nonsense. I want you to start at part A. Right, let's look at A. So for A, we have got e to the cos x. So when we think about e to the f of x, we said we're going to do, well, I'm just going to say y equals for now. We said f dash of x, so when I differentiate the top, I get minus sine x multiplied by e to the f of x. Yeah, so sine x times by e to the cos x, simple as that. So on your cheat sheet, you want how to differentiate sine f of x, cos f of x, e to the f of x, ln f of x, a bracket to some power. Okay, just so that you're getting all the little bits in there. All right, let me know how you get on with C once you're done with that, please. All right, so what do we have here? We have got, let's just call it y equals square root of ln x. Now that's the same as saying ln x to the power of a half. Okay. Now I've got bracket to some power. So how do I differentiate that? We've looked at differentiating some bracket to a power. Bring the power down. Take 1 away from the power. Times by the differential of what's inside the bracket. So I get 1 over x. And so you might write this as 1 over 2x ln x to the power of minus a half. Or you might have written this as 1 over 2x times by 1 over square root of ln x as well. Does that make sense?